Good morning everyone. I am Moni from Basic Chemistry Honors first year. Today I am read a chapter Cycloalkanes. What are cycloalkanes? Cycloalkanes are also called cycloparaffins. They are alicyclic compounds. They are both aliphatic and cyclic compounds, and their properties are almost similar to alkanes. Cycloalkanes are saturated hydrocarbons. That means all the carbons present do not contain any pi bond, or all other valencies are satisfied with a sigma bond. Cycloalkanes have a general formula CnH2n with the first member cyclopropanes are C3H6 isomerism. Cycloalkanes have a same molecular formula to the corresponding alkanes. So they are functional isomers with alkanes of same carbon number. For example, butane is a cyclic compound as cyclobutane. All three structures have molecular formula C4H8, but first two figures are the functional isomer with the third figure. Nomenclature. It can be written in three sections. Naming of simple cycloalkane. It is done by attaching the prefix cyclo to the name of corresponding normal alkene having the same number of carbon atom in the ring. For example, cyclopropane, cyclobutane, cyclopentane, cyclohexane. Naming of substituted cycloalkane. Naming of substituted and cycloalkanes are shown in first figure below. They are similar to that of straight chain compounds, but in second compound which is fused cycloalkanes, it's a typical 3-ethyl cyclopentane, 1,3-cyclopentadiene, 1,3-dimethyl cyclohexane, 1,3-cyclohexadiene, and it is bicyclo 2,2,1 heptane noborane. Let's break the name of bicyclo 2,2-heptane. Bicyclo implies the compound has two rings. If we break two carbons bond, the compound will be an alkane of 7 carbons, can be heptane. How the most important part of naming is 221. It is named because the number of carbon except bridged and shared carbon in 2 carbon 2 and carbon 3 2 carbon 5 and carbon 6, and the bridge is a headmate of 1 carbon 7. Example of typical cycloalkanes. Some typical fused cycloalkanes are given below. In cubane, each carbon attached to 3 other carbon. In a diamond, each carbon attached to 4 other carbon. This is a cubane and it is a diamond. Are not prepared for a student for methods of preparation. From dehalogenation compounds, suitable 1,3 or 1,4 like dihalogen alkanes on a treatment with sodium or a zinc gives the corresponding cycloalkanes. For example, 1,3 bromopropane react with sodium in presence of ethanols gives a cyclopropane plus 2 NaBr. From the calcium and barium salt of dicarboxylic acid. When the calcium or barium salt of adipic pymalic or sulfuric acid is heated, a cyclic ketone is formed, and cyclic ketone may be readily converted into the corresponding cycloalkane by means the mentioned reduction. When barium adipides react with the Ba in presence of a heat gives the cyclopentanone plus BaCO3. Cyclopentanone react with the zinc in presence of mercury gives the cyclopentane. थर्ड फ्रॉम एस्टर्स ऑफ डाइकार्बोक्सिलिक एसिड या फिर बोल सकते हैं डाइकेमन रिएक्शंस द डाइएस्टर्स ऑफ एटोपिक पाइबलिक और सब्सटिक एसिड when treated with sodium undergoes the intermolecular acetic esters condense and a keto ester is formed. The ketoester on hydrolysis gives the corresponding cyclic ketone. Cyclic ketone on reduction yields the corresponding cycloketones. Diethyl adipides react with sodium gives the following compound, and after hydrolysis it gives this following compound, and removal of CO2 gives a cyclopentanone. When it reacts with the zinc in presence of mercury, its reduction gives a cyclopentane. From aromatic compounds, benzene may be catalytically hydrogenated to elevated temperatures and pressures to yield cyclohexane. Chemical reactions. Cycloalkanes react mostly like their corresponding to the straight chain alkanes. Halogenation in presence of UV light. Production monosubstituted halogen without breaking the ring. The following reaction when the cyclopropane reacts with the chlorine in presence of UV light gives chlorocyclopropane. Addition of chlorine and bromine in presence of CCl4 in dark. Cyclopropane react with chlorine and bromine at a room temperature and in absence of diffused sunlight. They produce 1,3-dicyclopropane and 1,3-dibromocyclopropane respectively. One of the carbon-carbon bond of cyclopropane is broken and the two halogen atoms appear at the ends of the propylene in a chain. Cyclopropane react with chlorine in the presence of dark CCl4 gives 1,3-dichloropropane and 1,3-dibromopropane. Reaction with the concentrated HBr and HI produce the 1-bromopropane and 1-hydropropane respectively with the ring breaking gives cyclopropane react with HBr gives 1-bromopropane. Addition of hydrogen catalytic reduction. Cyclopropane and cyclobutane react with hydrogen in the presence of nickel catalyst to produce N-propane and N-butane respectively. Cyclopentane are higher members of the family do not give the reaction. Cyclopropane react with hydrogen gas in presence of nickel gas propane. Stability of the cycloalkanes. A stable organic compound means it very less reactive. By the term's stability, we get an idea about chemical reactivity of compound. To describe the stability of cycloalkanes, some very famous theoretical concepts are there: Wise Bayes strain theory, success mode theory, collision and Moffat's modification. Bayes strain theory. Adolf von Bayes, a German chemist and a Nobel Prize winner from the University of Munich, Germany in 1885, proposed a theory to explain the relative stability of first few cycloalkanes. The theory based on the following facts: cycloalkanes are saturated compounds, so all the carbons should have a normal tetrahedral angles of 109.5 degrees Celsius. Any deviation of the bond angle bond angle from the normal tetrahedral value would impose a condition of internal strain on the ring called the angle strain. More the value of angle strain, less stable the compound is. He assumed that all the cycloalkanes are flat and coplanar, which means are the two dimensions and present in one plane. Cyclopropane. In a cyclopropane, there the three carbon atom occupies the cones of an equilateral triangle. The cyclopropane has a carbon-carbon bond angle of 60 degree. This implies that the normal tetrahedral angle of 109.5 degree between any two bonds in compressed to 60 degrees Celsius, and each of the two bonds involved in a bonding by of one half is a 24 degree for 44 minutes. The value 24 degree 44 then represent the angle strain or deviation through which each bond bends from the normal tetrahedral directions. Cyclobutane. Here the four carbon atom occupies the corners of the square. So it has carbon-carbon bond angle of 90 degree and the angular strain of each bond is half of 109.28 minutes. Cyclopentane. Here the five carbon atoms lie at a corner of a regular pentagon. The cyclopentane has a carbon-carbon bond angles of 108 degree. The angle strain which each bond piles is half of this. Cyclohexane. In a cyclohexane, the six carbon atom occupies the corners of a regular hexagon. Cyclohexane has carbon-carbon bond angles of 120 degree. The angle strain will be half. Similarly, in the case of cycloheptane, the deviation from the normal tetrahedral angle is 9.33 degrees Celsius. In the case of cyclooctane, it is 12 degree 46 minutes deviation. The positive sign indicates that the carbon-carbon bond have to compressed to satisfy the geometry of the ring. The ring indicates that the carbon-carbon bond have to winded to satisfy the geometry of the ring. Whether the angle strain it is a positive or a negative, it is the magnitude to determine the extent of the strain. The deviation from the normal tetrahedral angle is the maximum in the case of cyclopropane, so it is the most unstable and open up to the sightless protection and they release the strain within. According to the Beer strain theory, cyclohexane and the higher cycloalkanes should have become increasingly unstable and hence have reactives. Drawbacks of a Weber's strain theory. The limitation of Weber's strain theory is that assumed that all cycloalkanes are planar. Weber's was unstable to explain the effect of angle strain in larger ring systems. According to the Beer's, cyclopentane should be much stable than cyclohexane, but particularly it is reversed. Large ring systems are not possible according to Bayes as they have negative strain, but they exist and much stable. Larger ring systems not planar but pucked to eliminate angle strain. Conclusion of Buffett modification on the band bond and banana bond. Conclusion of the Moffat modified Bayes' strain theory to show the actual position of carbon-carbon bond in a cyclopropanes, which somewhat relieves the strain of carbon-carbon bond. So to satisfy Tetrahedral geometry are equilateral triangles angle. They introduce a new type of bond called a banana bond and a band bond, which is intermediate between a sigma bond and a pi bond in case of overlapping. Sig- what is the band bond? Sigma bond have a head on a end to end overlapping the hybrid orbitals, including the interaction bonding region at present equally on both sides of molecular axis. But in the cases of the pi bond, it is a lateral or a sidewise overlapping of the pi orbital occur, and here the bonding interaction area is totally out of the molecular axis. In bent bond, the hybrid orbitals and interaction buildings are not present equally on the both sides of the molecular axis. The bonds are bent towards the direction of the angular strain, so they are somewhat more unstable than sigma bonds and less unstable the pi bonds. This is the question. Thank you.